Now, as you all are familiar with the methods that how we can prepare colloids. Now, after the preparation of colloids, we need to purify them also, because they are not pure colloidal solutions. Actually, they contain many electrolytes and many impurities. So, I will just write here that we need purification because there are certain electrolytes and there are certain impurities that are present in colloids. So, we need to separate them, right? We need to separate them from colloid because they will just interfere in the action of colloids. So, that means for purifying we need to apply imply certain processes, you can say. So, we have got three main processes which are used in the purification of the colloids, that is the dialysis, that is the electrodialysis, and that next is the ultrafiltration. So, we will be taking up one by one that actually what is the phenomena involved in this case and what is the phenomena involved in these cases and how we get to purify those substances. And I think it is clear that we need to purify colloidal solution from the electrolyte and the impurities which are present. So, see, this is our this is the method dialysis and this is our dialyzer. This is our dialyzer. Right. So, what we will be doing here in the dialyzer, what we will be doing here that when suppose we are, this is my you can say a beaker which contain a colloidal solution, this is my sole, you can say this is my sole. So, what happens like, and this is the water, this hole is the water. So, what happens like the principle behind this dialysis is that colloidal particle size is almost bigger if we compare it with the size of the electrolyte and the impurities. That means they are comparatively smaller. They are comparatively smaller in size. So, like when we apply dialysis, what we do, we take this, see this is a container, a closed container which has a water, and there is a, you can say a beaker, you can see, which contains the sole. See, actually this acts as a membrane, this acts as a membrane. So, we say that this acts as a membrane. So, what property does this membrane possess? It possesses small holes which will allow the smaller size particles to pass through but not the bigger one. So, likewise I told you that colloidal particles are bigger but electrolyte and impurities are smaller in size. So, what this membrane do? It actually allow the impurities to pass through. So, these are my impurities which are passing. It allows actually the impurities to pass through but does not allow the colloidal particles to pass through. So, what happens after the removal of impurities? We are just left with the pure colloidal solution. So, this is what happens when we carry out dialysis, and this is how we separate electrolyte and impurities, just based on the phenomenon that there is a special membrane which allows the smaller size particles to pass through but not to the bigger size particles. So, this is what happens here. Now, as you can see that here is the water present. So, you must be thinking that what is the function of water here? So, actually what is happening, that we are continuously pouring pure water from here and impure water is continuously taken out from here. So, what happens when pure water flows with the stream, it carries the impurities along and it is simultaneously removed, and more water enters, it takes the impurities along, again it moves from there. The reason behind is that, like if we do not remove the impurities, what will happen? A stage will reach when there will be an equilibrium. So, that means no more this you can say the impurities movement will occur through membrane. So, that is why we need to remove the impurities as soon as they are separated. We are trying to remove them so that the process of purification goes on, it does not stop at equilibrium. So, this is what we have dialysis. Now, this like if dialysis is a slow process, dialysis is somewhat a slow process. Like if we want to speed up this dialysis, what we need to do, the same apparatus, the same dialyzer, what we have to do, we have just applied the electric field. We have just applied the electric field. So, what happens when you apply the electric field? Same procedure is taking place. That is that as I told you, there is a membrane, right? So, what happens? Suppose we take an example. There is an electrolyte present, NaCl. Let us take, like as I told you, there is an electrolyte. So, let us take an example of NaCl. Suppose NaCl is present in a sole. NaCl is present in a sole. So, what happens when we will apply the current, when we will apply the electric field, oppositely charged particles will get attracted to the oppositely charged pole. And what happened? In the meanwhile, we will see that they start moving towards their opposite pole. And the neutral impurities, they start moving out as they were doing in the dialyzer. So what happens actually, this mechanism just speed up the reaction because there is an electric field, and that electric field, the oppositely charged poles will attract the oppositely charged particle towards it, and they will move with a faster speed. So what happens, we get to separate those electrolyte and impurities in a better way. That means the rate of the reaction, or you can say the rate of separation, just becomes faster. So the basic principle is the dialysis only, just it got modified that we applied an electric field. Now we have is ultrafiltration. So what we do in ultrafiltration, actually in this we like make use of filter paper. As you all are familiar that we have filter paper which has small holes in it. Suppose this is my filter paper, it has holes in it, right? And you know that like if I pass, like if I take a filter paper in a funnel and I pour the colloidal solution, what happens? Nothing gets separated because colloidal particles just pass through those filter paper pores. It is not stopped by them. Now, but if you use the graded filter paper, if we use the graded filter paper, it will somehow separate the electrolyte and the impurities. Now first the condition is that how to make that specialized filter paper. So what you do, you take an ordinary filter paper and you dip in a solution, or you can say dipped in a colloidal solution. Any colloidal solution. There are specific colloidal solution which are used according to like how much we have to reduce the size of pores. Accordingly we use those colloidal solutions. Like for ordinary filter paper, what we use 4% nitrocellulose mixed with ethanol and ether. Sorry, acetone and ether. So likewise, depending upon the concentration, we can use these colloidal solution, and depending upon that, we can have the graded filter paper. Graded filter paper is nothing but a ordinary filter paper. What we do, we just impregnate with the colloidal solution so that its pore size becomes reduced. This is only what happens with the graded filter paper. So like as we desire, like we want to smaller the size of the holes, so accordingly we can use the concentration of the solution. Like as I told you, for normal filter paper we are using this thing, right? So this what it do actually, it just decrease the pores of the filter paper. So what happens now, it becomes graded filter paper. It is able to separate the electrolyte and impurities. So we put this graded filter paper, let us say here, and we pour the colloidal sol from here. It will allow actually the electrolyte, the smaller size particle like electrolyte and impurities to pass through, right? But we are left with the colloidal solution. It will separate, just I'll explain you again. See, this is our beaker. What we have done, we have added the sol. So what happened, the size of the pore is so adjusted that it will not allow the it will allow the electrolyte and the impurities to pass through, but the colloidal solution will not pass. So it is left in this funnel. So this is how we get separate. I think you got it, that we put a sol here, and when we put a sol, what happens, we can also apply the pressure if you want to speed up, right? So what happens if you apply in a pressure of, if you don't apply in pressure, then the smaller size particle like the electrolyte and the impurities, because they are smaller than colloids, so they will pass through it leaving behind the colloidal solution, because colloidal solution won't be able to pass through that graded filter paper, that is the filter paper which is impregnated with some colloidal solution. So this is what is the ultrafiltration. So that means we can imply either of the method, like by using a membrane we can do dialysis. To speed up dialysis we apply an electric field and it becomes electrodialysis, and likewise we use filter paper in order to separate certain components. But here what we make use of, we make a use of ultrafiltration. That means a filter paper which is more advanced than the filter paper, because it becomes a graded filter paper, because we impregnate it with a colloidal solution in order to just decrease the size of the pore. So this is what is the purification.